Welcome to today's explainer. If you've ever spent hours meticulously architecting a neural network, getting your data set just right, and finally hitting run on that training script, well, you know that feeling of sheer suspense. Far too often, we treat neural networks like complete black boxes. We just feed our data in, stare blankly at a terminal screen for hours, or let's be real, sometimes days, and cross our fingers that the final output looks kind of like what we wanted. But hey, it absolutely doesn't have to be this way. We don't have to sit in the dark while our model learns, and today we're going to explore exactly how to fix that.
I mean, think about it for a second. How do you actually know your model is learning during a massive training run? Relying only on that final output to judge your network's performance, that is incredibly risky. It's basically like deciding to drive a car down the highway with a completely broken dashboard. You wouldn't just slam on the gas pedal and hope you aren't speeding, or just pray you have enough fuel to get there, right? No way. You need instruments. You need real-time feedback. Ultimately, you need visibility. So, here's our roadmap for this explainer. First, unlocking the black box. Second, getting your server started. Third, tracking the core metrics. Fourth, visualizing raw image data. And finally, number 5, building custom logging callbacks.
All right, let's dive right into section 1, unlocking the black box, a primer on TensorBoard. We really need to introduce the ultimate dashboard tool that's going to pull back the curtain on our neural networks.
And that tool is TensorBoard. It is this absolutely incredible, powerful visualization toolkit built specifically to track and visualize your network's performance over time, continuously, right as it trains. And you know what's really cool? The flexibility. So TensorBoard was originally built natively for TensorFlow, but you definitely aren't locked into that ecosystem. If you're a PyTorch user, you can easily tap into this exact same toolkit using the TensorBoard X library. So regardless of which of the two big deep learning frameworks you prefer, this entire dashboard is fully at your disposal.
Moving on to section 2, getting your server started, running locally. Because, well, before we can actually read the dials on our dashboard, we gotta turn the engine on. The setup here is beautifully straightforward, but it does require a few literal actionable steps. First up, you'll want to create a clean virtual environment for your project just to keep all your Python packages nice and organized. Second, you jump into your terminal and run the command you see here, tensorboard-logdir logs and. This command right here is the magic key. It creates a directory called logs right in your current folder, which is where TensorBoard is going to systematically store all the metrics from your training runs. Plus, that little ampersand starts the server as a background process. Finally, step 3. Just pop open your web browser and navigate to localhost 6006. And just like that, boom, your dashboard is live.
Oh, actually, quick but crucial caveat here. If you happen to be running your models on an AWS instance instead of your local machine, simply navigating to localhost just isn't going to work right out of the box. You absolutely must remember to open a port in your AWS security settings and set up an SSH tunnel directly to your machine. Seriously, do not skip those steps, or your shiny new dashboard is going to stay permanently locked behind the cloud's firewall.
Okay, on to section 3, tracking the core metrics, plotting losses. Now that the server is up and running, we can start peeling the onion a bit by looking at the surface-level metrics that tell us the basic health of our model.
To actually get the data flowing into TensorBoard, we've got to wire it up in our code using a callback. The logic here is wonderfully simple. First, you just import the TensorBoard callback into your script. Next, you configure the log directory. And here's a fantastic pro tip from our source material. Name this directory using a formatted string of the current time. This keeps your training logs neatly organized by timestamp, so you literally never overwrite your past experiments. Finally, you just pass this configured callback straight into your model.fit function. The framework handles the rest, automatically saving your data as the model trains. So once that training officially kicks off, head back over to localhost 6006, and you're going to find yourself looking at the Scalars tab. You can think of the Scalars tab as your vehicle's main speedometer. This is where you get the absolute most vital real-time reads on your network. You're going to see these beautiful, continuously updating curves for your training loss, your validation loss, and your accuracy over time. It is the immediate pulse check of your model's learning process.
But what if we want to look a little deeper under the hood? Well, it turns out making just one tiny modification, setting histogram freak equals 1 inside the TensorBoard callback constructor, actually instructs the system to go one level deeper into the inner mathematical workings of your network.
And the really crucial point here is that this single parameter completely unlocks the Histograms tab in your dashboard.
Here, you can literally monitor the actual distributions of the weights inside each specific layer of your network, and you can do it at every single epoch. So why does this matter? Because tracking these histograms is how you definitively know your weights are actually updating and learning. It's exactly how you spot catastrophic issues, like your weights just vanishing into the void or exploding way out of control, long before your final accuracy numbers tell you something's gone terribly wrong.
All right, section 4, visualizing raw image data, logging images. Numbers, curves, and histograms are all fantastic, but sometimes, we really just need the literal visual GPS view of what our model is dealing with. And that brings us to visualizing raw image data. You can so easily use tf.summary to log actual image data directly into TensorBoard. Say, for example, you're working on a classification task with the classic MNIST dataset. You can just log the first 5 examples from your training set. Then, by checking the Images tab, you can physically inspect them. This acts as an immediate visual confirmation that the data your model is chewing on is correctly formatted, cropped, and oriented. You verify with your own 2 eyes that the inputs actually make sense.
Finally, we arrive at Section 5, Building Custom Logging Callbacks, Advanced Tracking. This one is really for the advanced users out there. We're going to explore what happens when the standard out-of-the-box logging just isn't cutting it for your specific architecture.
You see, the standard logging we just talked about, like throwing a few images into the log at the very start of training, that's a fantastic start. But let's face it, it has its limitations. Mostly, it's pretty static. To truly understand complex models, we really need continuous, custom insights that are generated at specific intervals over the entire course of the training run. That is where the real illumination happens.
And this brilliantly illustrates exactly why we sometimes need to write custom logic. Just look at this comparison. For standard classifiers, those loss and accuracy curves we saw back in the Scalars tab, they usually provide more than enough insight to know if things are working out. But if you're training something like a generative adversarial network, a GAN, those exact same loss curves are notoriously misleading. The generator and discriminator losses oscillating up and down don't actually tell you if the model is creating good images at all. For GANs, you absolutely must be able to view the actual samples generated over time to see if the visual quality is getting better. One size definitely does not fit all.
So this is exactly where Lambda callbacks come to the rescue. They basically let you define custom logging behavior that executes at fixed intervals, say at the end of every epoch. So instead of just relying on a single simplistic accuracy number, you can use Lambda callbacks to track rich, dynamic visual artifacts. You can literally watch the evolution of your confusion matrices. You can track ROC curves as they shift over time, or you can log those absolutely crucial generated image samples from your GAN directly into TensorBoard. And honestly, it's pretty amazing how elegant this code actually is in practice. Here's a specific snippet directly from our source material. CM callback equals lambda callback on epoch end equals log confusion matrix. In this specific scenario, we've defined a custom function called log confusion matrix. That function uses the scikit-learn library to calculate predictions against the validation set and then plots a confusion matrix image. By passing it to on epoch end inside a lambda callback, TensorBoard is going to automatically plot a brand new confusion matrix at the end of every single epoch. So what you get is this complete historical flipbook, showing you exactly where your model is making errors across different classes as it learns. So look how far we've come. We went from staring blindly at a terminal to building a fully customized, real-time visual dashboard tailored exactly to our needs. I really want to leave you with this question to chew on. What is the one critical metric you've been entirely ignoring in your current machine learning project? And can you build a custom callback for it today? It's time to stop training your models in the dark. Turn on the dashboard, unlock the black box, and truly take control of your training process. Thank you so much for joining me on this explainer, and happy building!